Good day for all of you. Welcome to another Connection Wednesday, March 21st. The first thing today, I have to apologize you because our pretty woman product engineer Jana Kadirova is currently ill and I'm only backup, so I hope it will not be disaster today. With me is here Adam Kozhoušek and we are product engineers of Ideastatika. As usually, we have a control panel in the go-to window. Please ask questions by this question panel anytime you want. We will try to answer them all during the session. Adam prepared for you a new customer project from Rumble, a frame with tubes through it, and he is really excited to show it to you. As a small help desk highlight, I will show you a small trick how to disable loads if you have plenty of them. At the end of our webinar, there will be a time for questions and answers. So now it's time for my colleague Adam. Adam, please show us the great joint.
Okay, greetings, good day to you. It's Adam here. Today, instead of Jana, there is Vitek presenting. So it's another nice colleague in our office. So let's get back to the example we prepared for you today. It's the customer project of Kistefos Museum. Kistefos is a place in Norway, and this is a amazing project from my point of sight. From my point of view, it's a combination of a building, sculpture, and a bridge. So it's basically a bridge over the river of Kistefos, including a museum inside, and itself, it is a great piece of architecture that was designed by a big group of architects, and the structure was designed and calculated by Ramboll. That's a Danish engineering office. And so they used for design a Tekla software, and they code checked the joints with Ideastatika connection software, and of course they used the BIM-link with Tekla to Idea as well. And I'll show you how to model one of the joints from scratch. So let's get to that. So let's just start a new project, and as usual I'll just choose the material 355 steel grade and some starting topology, this 3D cross frame, and I will modify this geometry to the one I need. So I'll start with the column, change from continuous to ended, and I change the cross section. This will be the basic frame, which is made of HEM cross sections 600. Now I continue with the member B1. This is also the same cross section, and this will be also the bearing member. Okay. Then I continue with the member B3 and B4. Those will be the tubes intersecting the beam B1. So for that, I will change the cross section to a general tube, because this was the cross section Rumble used was out of the library we have. So we can simply input it this way, just set the diameter and thickness, and get it there. By default, maybe you noticed I have some digits after the comma. If you want to have it more precise in any part of the software, you can easily change that here in units. And here you can change the decimals after the comma. So if you miss some, you can make it more precise. Like for now, I added 1 digit after the comma. So that was just a side tip for you. And let's get back to this. I'll set the length here and the angle. And for the B4, the same cross section and the angle like this. So we make this tube like something like continuous going through and through. I will show you at the end a trick how to do it properly, but this is how the model was created originally. So I just follow the original setup. So for the last one, member B2, it's again a tube length of 1800 and again a general tube of cross section of 306, and the thickness is of 16 millimeters. And of course, I have to change the angle here, so it will be minus 8.6 and minus 66.9. So this is the basic geometry setup for the joint, and we continue with the load effects. So in this case, I will turn on the check equilibrium, so we'll be able to load all the ends, including the bearing member. And I will go to the folder where I have my forces saved. So as we can see, we have a lot of combinations here. Probably my sharing stopped. Can you confirm that?
Yes, I see the Excel spreadsheet.
Okay, good. Okay, good. So here we have a list of internal forces from all the combinations for this joint. So there's a lot of them. So for now, I'll just import one of them, and colleague Vitek will comment that later when he will take his word. So okay, just imported the forces right in the place for each member. Just the usual case. And we move on to design, and we'll start designing the joint. So I will start first with the operation cut, and I will lengthen the B1 column. So I set it as father and leave their offset of 60 millimeters. Okay, then I will cut the the column by the beam B1 like this, and I just changed the weld thickness 15 millimeters and have double fillet welds. So I have this connected. Then I will add stiffeners operation to the B1 member, and it will be related to the column SL. So now I change the thickness, and again set the weld thickness and weld position like this. And they're on both sides, of course. Okay, so we have the main frame modeled, and now we will do with the tubes. So one, let's say, workaround to do a continuous tube through a member is to cut both of ends and weld them to the member web in this case. So I will do this. So I take the member B3, that's the tube, and cut it by B1 and bound in box. Okay, and I just change the weld thickness, and I can turn on off the flanges because there is no flange on the tube. So we have one side of the tube that's going through connected, and I do now copy of this operation and set it for the B4. And we have it like through tube going through this frame. And then I will show you a trick how to do it the other way. So for now, we are satisfied with this. And we continue by connecting the B2 tube. So I will use a connecting plate operation. And I will pick the default bolt assembly grade and size like this. And I will be connecting the tube B2 related to B3 tube, which is this one. And I will just now modify the operation. So I'll set its geometry properties in the shape I need it. So I'll change thickness here. I'll change here from alignment front to center, and from the cap plate to notched member. I can maybe explain you a little bit difference between these three notched types. If I switch to transparent, you can see notched member means that you cut the plate into the member. So now the member is cut. If I switch to notched rectangle, it means you cut the plate inside the tube and weld it around. And if I switch to a notched plate walls, then again the plate is cut around the member web or walls like this. So this is the three types of notched cut, let's say. So I'll pick the notched member in this case and continue with changing the parameters here, weld size, weld position, like this. Okay. Here I forgot to change the thickness to 40. Okay. So this was the first step, and we continue now in modeling. So I will add now a stiffening plate to connect those two plates together. So this operation, and again, first I will set the geometry values like this, and I will set the origin from joint that is now here in the center node of the joint. Change this to plate and set it for this plate, which is CPL1B. And now it became a rip by default, and I will change this to doubler. And from the front size, which is below, to the rear size, which is up here. Turn off the welds and move the whole plate towards the connecting towards the gusset plate. Okay. Now I'll just copy this for the other side as well. So I change to front. So we have both plates in position. And I will now add bolts to connect those two parts. So I'll be counting or bolting 3 plates, which will be the SP1 plate, the CPL1B plate, and SP2. So now they glow all 3 orange. So I have it set right. And of course, I will change the position of bolts like this. And I will just copy this operation and add these bolts here. So the only thing here I have to do is change the position of the bolts to minus to get it in the other, for the other plate, for the gusset plate. Good. And the last thing is to shape this gusset plate. So we'll go to the editor and shape the gusset plate. And we will use the bevel operation. So I add 1. And we'll be beveling corner number 2. And by these values, let's see. Okay, it's looking good. And I will add another bevel operation to cut this part off. And that will be the corner number 3. And cut by 180 and 360. All right. Switch to transparent. You can see the gap is here. Everything's looking good. The last thing here is to cut the tip of the gusset plate here. So I'll add the last operation, cut of plate. And I will be cutting CPL1A, which is the gusset plate. And I'll be cutting it by plate of member, B1, this one, and by its web. And now we see it disappeared, but that's not an error. It's just the other surface that cut it. So we just change it to the minus. So we'll have the rest here. And I change the welds to double fillet welds to have it on both sides and change its thickness. Okay, so we're done with the modeling here. Now I just calculate the joint and oops, I have the bolts set wrong. Probably I set the wrong digit here, wrong value, but it doesn't matter because still I want to save time not showing the calculation, and I have it calculated here already to show you the result. So in the overall check, we can see quickly that this is this passed the code check. This joint is okay, very well designed as well, because we can see it's up to its limits or up to its capacity. Most of the parts are green and these welds are orange. That means up to 95.9% of its utilization. So if we just quickly go through the results here, you can take a look at the equivalent stress, mesh and deform shape of the joint. So we can check the stress distribution along the joint, and yeah, also check the strain where it occurs. This is mostly in elastic state, just some welds are in plastic state. Okay, I'll just finish this result browsing, because that's the usual process you do every time at the end of modeling in IDEA Statica. And I wanted to show you how to do the trick with the continuous through tube. So let's get back to the project here. I will simplify it so it will be more visible. So I'll just turn off the operations here. I will just leave the basic frame and the stiffeners maybe. So I go back to geometry. I will turn off the B4 member and also to have better visibility B2. And I will now work only with the B3 member. So I will change the geometrical type from ended to continuous. So now it's really going through, as we can see in transparent mode. And then I go to design, and here I will just do one operation, cut of plate. So I'll be cutting this plate by this tube member. So this plate is member B1 and it's plate web1, and I'll be cutting it by member B3. And I have to change the cutting method to surface. Now, if I switch to transparent mode, we can see that the web of the beam B1 is cut. There is a hole, and the tube goes through it. And of course, I can play now with the welds to have it as a full weld on both ends or both sides. So this is a trick for you how to model a really through and through tube through plates or members. Okay, so that was for my part, and I give word to Vika that will show you the disabling load trick.
Thank you very much, Adam, for the effort. And we can continue with the help desk highlight. We had a question, how to disable loads. Well, in the version 8.2, we have to use a workaround. So let's jump in right to the application. I will open the same project as Adam showed you a few seconds later. Let's go to the load effects. You can see we have plenty of them. in effect almost 600. And as you can see, we don't want to analyze the joint for all load effects because it will take a lot of time. So let's back up our load effects. We can export them all. I will save my backup to the desktop. And now I can delete all of them and keep there 1, 2, 3 of them. Just give me a second, I will delete a few of them. Okay, let's say I decreased the number of load effects and I'm satisfied now. Now I can, of course, check the joint and fine-tune it. And if I'm satisfied, I will delete all of them. And I can import again all load effects which I saved as a backup. It's right here in the Excel spreadsheet file, and this is the export function from IdeaStatica. I will choose only, for example, 18 of them, press Ctrl and copy, and paste them here. Let's confirm it, and we imported backup forces load effects. Now we can run analysis again for a whole set of load effects. Many of you already know, in 2 weeks we will have a release of new version 9. And I want to show you one small sneak peek preview from version 9, and we will talk about the load effects. Okay, here is our project, same one. You can see here at the right part of the 3D scene, we have a new control object. We call it tree of all entities, and here we have load effects, all of them. And you can see that we have a check button, and we can turn off and on everything that we need. So simply by clicking, I will turn off the load effects that I don't want to use for code check. So I can fine-tune my joint for 1 or 2 of them, save time, and then when it's over, I can turn it on and run analysis for a whole set of them. Let's jump back into the presentation. This is all from our webinar, and I have to ask you about filling of short survey, which will be after the webinar. This survey will help us to make these webinars better. It's for you. It will take you only a few seconds. Please fill it. Recording of this webinar will be available tomorrow at our YouTube channel and in our webinars tab at homepage. Also, if you're not a trialist, you can get a trial version at ideastatica.com by filling a small form. And don't forget, we have Resource Center where you can find all tutorials, webinars, videos, theoretical background, and many more. We recorded all webinars so you can study it in your free time. And next Connection Wednesday webinar will be at April 4th. And right now, we are looking forward to it. Thank you very much for your attention and have a nice day.
Wish you a nice day. Bye-bye.